Hey guys, welcome to my channel. Have you ever wondered how, in just a few decades, China transformed from having nothing into a global infrastructure powerhouse? The answer is hidden in this land bustling with activity. China, hailed as the infrastructure maniac, Chinese engineers have written their own legend through a series of world-shocking megaprojects. The once arrogant United States, upon witnessing China's true infrastructure might, had no choice but to bow down. They knew that many of the projects China built were simply beyond American capability. Former US President Trump once openly declared that America would never be able to compete with China.
I love China. People say, oh, you don't like China. No, I love them. But their leaders are much smarter than our leaders. And we can't sustain ourselves. China, you go there now, roads, bridges, schools, you never saw anything like it. They have bridges that make the George Washington Bridge look like small potatoes. And they're all over the place.
When it comes to constructing large-scale projects, China literally clears mountains and builds bridges over waters, forging ahead through every obstacle just to create one engineering marvel after another. So, just how incredible is China's strength in infrastructure? And what untold secrets lie behind the nation's cutting-edge construction technology for mega-projects? In this video, we will delve deep into the stories behind China's giant engineering feats. Before we begin, we sincerely invite you to subscribe and turn on notifications so that you won't miss any of our exciting updates. We truly value your thoughts and look forward to hearing your opinions in the comments on these outstanding Chinese achievements. As one of the world's largest developing countries, China has long driven its economic and social development through infrastructure. Its engineers are like superheroes in the field of construction, dedicated to creating monumental projects that meet the demands of a continually growing population. From the Goupitan Hydropower station rising from the banks of the Jinsha River to the spiraling tunnel of the Yashi Expressway that seems to float among the clouds, from the world's highest Qinghai-Tibet Railway to the Hong Kong-Zhuhai-Macao Bridge spanning the Lingdingyang, from the hellish difficulty of the Sanyuan Railway to the 50-meter deep tunnel under the Pearl River estuary, Chinese engineers have redefined the limits of human infrastructure with projects once thought impossible. While Americans were still embroiled in debates over repairing century-old bridges, China was reshaping the surface of the Earth by constructing 16,000 kilometers of highways and 4,000 kilometers of high-speed rail each year. When China's railway network in 1949 measured only 21,000 kilometers, with half of it in disrepair, who could have imagined that 75 years later, the nation would weave a traffic network spanning 45,000 kilometers of high-speed rail and 180,000 bridges, enabling people to travel thousands of miles in a single day? Behind these achievements lies an Eastern wisdom that has upended Western perceptions. During the construction of the Hudong-Yangtze River Bridge, China has developed a specialty steel possessing a tensile strength of 500 MPa. Equivalent to a steel cable as thick as a chopstick lifting 3 main battle tanks. This breakthrough in material means that a cable-stayed bridge designed for both road and rail, with a 1,092-meter main span, is no longer merely a theoretical concept. As the world's first road-rail cable-stayed bridge with a main span exceeding 1,000 meters, it not only serves as the golden link of the Yangtze River economic belt but also stands as the pinnacle of Chinese infrastructure innovation. The bridge features a main span of 1,092 meters, with two 330-meter high diamond-shaped main towers soaring into the sky equivalent in height to a 110-story building. These towers bear an axial force of 300,000 tons, functioning like the mythical CC Elming needle that stabilizes the waters, their foundations firmly anchored in the riverbed. To conquer the complex hydrological environment of the lower Yangtze River, engineers pioneered a groundbreaking precision positioning technology for a 15,000-ton steel caisson. They constructed a colossal caisson foundation spanning 5,100 square meters on the dynamic, sediment-laden riverbed, equivalent in area to 12 basketball courts, setting a world record. The bridge employs self-developed ultra-high-strength steel that surpasses conventional materials in strength, paired with 2,000 megapascal grade stay cables. This steel and concrete framework supports a superload of 480,000 tons of steel and 2.3 million cubic meters of concrete, equivalent to the steel used in 12 Birds Nest stadiums and the concrete volume of 8 national grand theaters. By reducing the travel time between Nantong and Shanghai from 5 hours to just 1, the Hudong Yangtze River Bridge has revitalized the Yangtze River Delta's transport network, effectively unblocking the region's critical arteries like the meridians in traditional Chinese medicine. The bridge carries the Tongxi Expressway, Huzutong Railway, and Tansujiayong high-speed rail, handling over 100,000 vehicles daily and 80 million tons of annual freight, forming a super corridor linking coastal economic zones. Its 1,092-meter-wide main channel accommodates 100,000-ton vessels, achieving harmonious coexistence of maritime and land transport. International netizens marveled at the spectacular steel beam closure process. Through the Hudong Bridge, Chinese technical standards are gaining global recognition. As foreign media noted, while other countries are still debating how to build bridges, China is already defining the future through its actions. Beneath the waves of the Lingding Channel, a 6.7-kilometer steel leviathan silently intertwines Hong Kong, Zhuhai, and Macau. This is the Hong Kong-Zhuhai-Macao Bridge's undersea tunnel. This engineering marvel, the world's longest road-immersed tunnel, stands as the pinnacle of China's infrastructural wisdom and daring. But why did Chinese engineers choose this underwater path? The answer lies in dual challenges. Lingding's waters host both bustling international shipping lanes and flight paths beneath Hong Kong International Airport. Traditional bridge towers would have endangered maritime navigation and aircraft operations, while dynamic seabed sedimentation made conventional piers unstable. Demonstrating extraordinary vision, Chinese engineers pioneered a revolutionary bridge island tunnel cluster design. Artificial islands now seamlessly transition surface bridges to submerged tunnels, simultaneously safeguarding navigation, overcoming airspace restrictions, and conquering geological complexities. At Zhuhai's Nyoto Island, in the world's largest immersed tube prefabrication facility, 33 massive tube sections were quietly produced. Each section is 180 meters long and weighs 74,000 tons, comparable in scale to a medium-sized aircraft carrier. Engineers pioneered the curved immersed tube factory method, fabricating curved tube sections with a radius of 5,500 meters to millimeter-level precision, breaking free from the limitations of straight-line production. Once towed from the prefabrication yard to the construction site, these tubes must navigate complex ocean currents. A formation of 8 high-powered tugboats, coordinated by satellite positioning and an intelligent control system, precisely delivered each tube section into position. Then, harnessing the buoyancy of water, the immersed tube gently descended 44 meters to its seabed foundation trench. Through China's independently developed deep-water unmanned installation system, an astonishing joint tolerance of merely 3 millimeters was achieved between tube sections, a precision feat lauded by international media as the subsea kiss of perfection. Traditionally, immersed tubes rely on risky underwater welding to ensure watertight seals. Chinese engineers pioneered a revolutionary active compression sealing technology. They installed retractable steel bulkheads at tube ends, employing hydraulic systems to actively compress rubber gaskets, transforming manual processes into mechanized operations that guaranteed absolute water impermeability. This innovation enabled the final joint installation to be completed in just 1 day, achieving a 10-fold efficiency improvement. To monitor the immersed tube's positioning, engineers deployed high-precision, microelectromechanical gyroscopes and tilt sensors, capturing ultra-low-frequency motion data in real time. This ensured the 33 tube sections fit together with the precision of interlocking building blocks. At both ends of the tunnel, the artificial islands feature steel cylinder retaining structures, 120 steel tubes, each measuring 22 meters in diameter, are driven deep into the seabed, forming a robust foundation that withstands ocean currents and typhoon forces. From the Øresund Strait in Denmark to Busan in South Korea, no immersed tunnel worldwide had ever exceeded 3.5 kilometers until the Hong Kong-Zhuhai-Macao Tunnel rewrote history with its staggering 6.7-kilometer span. International media marveled. 33 colossal tubes aligned on the seabed with a cumulative error less than the width of a human hair. Chinese engineers have redefined the limits of deep-sea engineering. More than a physical passage, this tunnel symbolizes China's transformation from an infrastructure follower to a standard setter. Through this 6.7-kilometer undersea marvel, China demonstrates that its engineering prowess can tame the vast oceans, inscribing a new chapter in the annals of human engineering. In addition, Chinese engineers have constructed another colossal engineering project that has astonished the world, the Shenzhen-Zhongshan Link, an engineering colossus spanning turbulent waters, a core transportation hub project in the Guangdong-Hong Kong-Macao Greater Bay Area, stretching 24 kilometers in total. This project is an integrated cross-sea engineering feat combining bridges, islands, tunnels, and underwater interchanges, including an undersea tunnel that spans approximately 6.8 kilometers. In this tunnel, engineers embedded 23,000 fiber optic sensors within the immersed tubes, allowing the concrete to sense stress changes in real time, much like human nerves. This technology is 40% more sensitive than its Western counterparts, prompting even the journal Nature to exclaim, "The Chinese have taught concrete how to think." Next, we will examine in detail how Chinese engineers built this undersea tunnel. This tunnel, 6.8 kilometers long, is designed with 8 lanes in each direction, 2 more lanes than the Hong Kong-Zhuhai-Macao Tunnel. It is composed of 32 giant immersed tubes and a final joint, buried more than 40 meters beneath the sea. When Dutch immersed tube specialists declared an 8-lane bidirectional configuration impossible, Chinese engineers staged a subsea engineering marvel in the Pearl River estuary, deploying an innovative steel-concrete sandwich composite structure that defied Western engineering conventions. Traditional immersed tube tunnels typically employ cast-in-place reinforced concrete, a process that is both labor-intensive and time-consuming. For the Shenzhen-Zhongshan Link's undersea tunnel, engineers adopted a steel shell design. However, the 8-lane configuration significantly widens the tube structure, with each additional lane increasing hydrostatic pressure by 27%, approximately 20,000 metric tons per lane. This equates to bearing the combined weight of 15,000 sedans. Compounding this challenge, the overhead navigation channel accommodates 10,000-ton cargo vessels. The dual pressures from hydrostatic forces and shipping loads create a structural conundrum akin to crushing forces on a beverage can, potentially causing tunnel deformation. After thorough research and verification, Chinese engineers decided to use a steel shell concrete structure. In essence, the process begins with fabricating the tube's steel shell, followed by concrete infilling, a composite construction method that significantly enhances compressive strength while eliminating traditional rebar tying. This innovative hybrid structure achieves a 400% increase in flexural rigidity, a breakthrough so transformative that the American Society of Civil Engineers has incorporated it into their latest design specifications. The immersed tube is manufactured in an automated facility, where steel plates are precision cut into various profiles, then robotically welded. Intelligent welding robotic arms achieve 0.02 mm seam alignment accuracy, the error being only a third of a human hair's thickness. Certification testing by Germany's TV Rhineland confirms that the weld quality exceeds DIN 6700 standards by 22%. Due to their enormous size, each tube is divided into 22 segments. After each segment is completed, a gantry crane assembles them, followed by final assembly work by the crew. Besides the robust and watertight exterior, ensuring that the tube remains corrosion-free for 100 years underwater is key. After the steel shell is completed, its surface is sprayed with 5 layers of anti-corrosion coating with a molecular structure that mimics shark skin, leaving no foothold for algae or bacteria. Each tube is then equipped with 552 sacrificial anodes, ensuring that under their protection, the tube can be safely used for a century. Next, the tube is transported to another facility for the final concrete pouring. The underwater immersed tubes of the Sanyuan Bridge are designed with a steel shell concrete structure. Once the steel shell is completed, its inner chamber is filled with concrete. The total volume of concrete for 32 tubes exceeds 1 million cubic meters. At this point, manual labor could no longer keep pace, necessitating the use of intelligent concrete pouring robots. These robots autonomously move along predetermined routes on the tube's top slab, automatically detect and drill holes, and perform the pouring operation entirely on their own. Using 1,200 sensors to continuously regulate the concrete's flow rate, these smart robots compressed a process that traditionally took 90 days into just 28 days. Even more astonishing is the zero manual vibration technique. Self-compacting concrete flows like melted dark chocolate into every crevice with nanometer-level precision, comparable to the intricate distribution of capillaries in the human body. To formulate the optimal composition ratio, engineers dedicated 3 years to systematic experimentation, even building a full-scale tube module to simulate the tube's ability to withstand more than 1,000 typhoons and resist a level 9 earthquake, as well as a scenario in which sea levels rise by 3 meters by 2075. This die-before-rebirth Eastern philosophy reduced the project risk by 83%. These simulation tests effectively validated the reliability of using this specialized concrete in the immersed tubes. Although this concrete's strength and flowability meet the requirements for casting the tubes, once it leaves the batching plant it must be poured within 90 minutes. This critical requirement led to the creation of an intelligent manufacturing facility capable of casting 1 tube section per month, earning its reputation as the Smart Dream Factory for immersed tube prefabrication. A complete steel shell immersed tube weighs as much as 80,000 tons. Moving it a mere 200 meters to the departure area is no small feat given its massive weight. With 200 transport vehicles and over 1,000 steel wheels, the 80,000-ton tube was slowly moved and transferred in just 4 hours, a task that used to take 7 days for a tube of similar mass. Before a tube can be brought in or out, workers must conduct final inspections. Using millimeter precision, non-destructive testing equipment, the density of the concrete can be assessed without damaging the steel shell. Once approved, the tube is fitted with a ballast water tank and steel sealing doors, then maneuvered by buoyancy into a deep water dock. Next, it is ready for installation. How do you excavate a 5-kilometer-long, 330-meter-wide deep-sea trench 40 meters below the surface? The answer lies in the choice of construction machinery. In the undersea tunnel section of the Sanyuan Bridge, the seabed is scattered with uneven weathered rock. Before laying the immersed tubes, the seabed must first be leveled. This is where specialized drilling tools come in. A 35-ton drilling hammer, weighing as much as 3 main battle tanks, free falls to shatter granite. Each impact releases energy equivalent to 2.5 kilograms of TNT, yet it can control the trench's precision within plus or minus 4 centimeters, more stringent than the installation standards for benches in New York's Central Park. Meanwhile, another vessel uses a powerful grab bucket to clear out rubble. If excavating the trench is like laying a bed for the tubes, then throwing and leveling stones is like adding a mattress, a crucial step to ensure the precise alignment of the tunnel's tube sections. The Jinping No. 2 leveling vessel is the star of this phase. Upon reaching the exact location of the tunnel, 70-meter-high support pillars are driven into the seabed for positioning, and rubble is transported via conveyor to the stone-laying pipe. The discharge outlet then lays the stone evenly at a regulated speed on the seabed, maintaining precision within 4 centimeters. Every 4 days, the leveling work for 1 tube section is completed. Once the tunnel's trench is prepared, the world's first integrated floating and installation vessel, Jinan No. 1, sets sail carrying an 80,000-ton immersed tube out of the dry dock. At 1 o'clock in the morning, Jinan No. 1 successfully reached the lowering position. Under the guidance of cables, the tube was slowly lowered until it reached the trench, where it was connected to the previous tube section via pole rods. To ensure installation accuracy, divers went underwater to transmit real-time images. After a final hour of fine-tuning, the deviation at the joint was reduced to an astonishing 0.8 millimeters, thinner than a human eyelash, breaking the world record for underwater immersed tube alignment. Dutch supervisor Janssen recorded in his log, "This is the Apollo moment of engineering." Now that the Shenzhen-Zhongshan Bridge is fully operational, a brand new landmark mega project spans the Pearl River estuary. When the first car's headlights pierced the darkness of the undersea tunnel, it was not just the rebirth of a transportation artery, but an epic dialogue between humanity and the ocean. Chief Engineer Song Xinyu told reporters, "We spent 16 years turning a wild idea on paper into a routine reality that millions cross every day." Regarding this project, the chief engineer further elaborated.
我们这个项目刚好位于粤港澳大湾区的几何中心，它周边的建设条件异常的复杂，它的防洪纳潮也比较敏感。我们开展了52项相关专题的认证，其中通航就开展了19项平行的认证工作。我们最后也是用了一个全球首例桥岛隧水下枢纽互通4位一体的一个集成跨海工程方案。当然也有我们北斗定位系统的贡献啊，最后实现了连续17个管节毫米级的这种安装精度。
If the Hong Kong-Zhuhai-Macao Bridge is a maritime link binding Guangdong, Hong Kong, and Macau together, then the Shenzhen-Zhongshan Bridge is the key to opening up the golden inner bay of the Pearl River estuary, further boosting economic development in the Greater Bay Area. Chinese engineers have built heavenly ladders in the mountains and dragons on the seas, creating a transportation network that enables thousands of miles of travel and seamless connectivity across lands and oceans. What once were unimaginable feats have now become everyday realities in China. With its global leading scale, complexity, and speed, Chinese infrastructure has become a shining national card that captures the world's attention. From the lofty Yashi Expressway to the bridges and tunnels carving through the towering mountains of Sichuan and Chongqing, breaking 7 world records along the way, China has turned natural obstacles into thoroughfares for economic and social development, significantly improving people's livelihoods and paving the way for rural revitalization. The Hong Kong-Zhuhai-Macao Bridge is the most technologically complex, challenging, and massive bridge in the history of road construction, setting multiple world records and establishing core technologies with independent Chinese intellectual property rights. In 2024, with the opening of the Shenzhen-Zhongshan Bridge and the Huangmao Cross Sea Bridge, the Greater Bay Area will realize the one-hour living circle. Roads and bridges have shattered the constraints of time and space, fostering coordinated socio-economic development. The expansion of China's railway network and breakthroughs in independent research and development have dramatically transformed the lives of its people. In a country boasting the world's largest high-speed rail and highway networks, traversing thousands of miles in a day is now a part of daily life. Have you ever imagined that a ship could sail over mountains? And this isn't like something out of a movie or a dream, it's a reality. You can turn your fantasies into reality. And to do so, you must come to China. In the modern world, all of this is only possible thanks to dams and hydropower systems. Approximately 1/3 of the world's installed hydropower capacity comes from China. This is not surprising, as there are countless hydropower stations in the country, some of which have even set world records. For example, in China there is a dam called Goupitan, one of the largest hydropower stations on our planet, with an installed capacity reaching 1 million kilowatts. Its scale is enormous and its annual power generation is truly remarkable. Although its installed capacity is lower than that of the Three Gorges Dam, it still ranks as the second largest hydropower station in the world. In fact, the world's top 5 hydropower stations are all Chinese projects. In this country, people can actually make ships sail over mountains. In today's video, you will learn how Chinese engineers accomplished this feat. They used ship lifts to turn fiction into reality. This is the Goupitan hydropower station, where the dam stands 232.5 meters tall, and the total lift height of the ship lift reaches 199 meters. Equivalent to 66 stories. Ships are raised in 3 vertical stages to bypass the dam, traveling directly from the lower to the upper reaches of the Wujiang River, making it one of the world's largest ship lifts. So, how does this ship lift actually operate? First, a 500-ton vessel enters a gigantic ship-carrying chamber measuring 40 meters in length and 12 meters in width. The chamber is flooded with water to create a moving waterway. It is towed by 256 steel cables and is raised and lowered vertically via a gear rack climbing system, with each stage taking about 30 minutes. The ship must ascend through 3 levels of the ship lift, taking a total of approximately 2.5 hours, reducing the journey by 4 days compared to traditional winding mountain routes. Employing a world-first gear rack plus nut column safety system that can withstand an 8-level earthquake in extreme wind and waves, the lift's precision is maintained within plus or minus 10 millimeters, ensuring that 1,000-ton class vessels can traverse the mountains smoothly. This project has restored full navigation along the Wujiang River, opening up the golden waterway that connects Gorges to the Yangtze River, increasing annual freight capacity to 5 million tons, and boosting the development of the Central Gorges Economic Zone. The International Shipping Association has even described it as redefining the possibilities of inland navigation. Now, observe a ship sailing along a canal that, upon approaching a tall building, enters its interior. Inside this structure, a lifting cable hangs, flanked by 2 rows of drums and gearboxes on either side. To residents of a typical multi-story building, such an elevator might seem both incredible and sluggish, given its enormous internal footprint. However, the designers claim that this ship lift can raise and lower a 500-ton vessel in about 10 minutes. In other words, a standard passenger ship can easily depart from its original position in such a short time. The massive lift has a maximum load capacity of 18,800 tons. Even though a vessel might take a bit longer to be fully raised, hardly anyone cares because any waterborne vehicle will be lifted to an astonishing 72-meter height. Incidentally, this height can vary depending on the downstream water level, with a maximum lift of up to 200 meters. Some have even called the ship lift system at the Goupitan Dam an incredible feat of engineering. Of course, such praise is open to debate, since ship lifts have been implemented in various parts of the world for some time. However, you will notice that this system does not consist of a single elevator. It actually comprises 3. Following the first elevator is a second one that raises vessels to a height of 130 meters. Its operating principle is straightforward. The ship enters, waits for the system to activate, and is then raised as a whole. Through the Goupitan Dam's lift system, the water surface of the entire shipping channel is elevated to 199 meters, simply unbelievable. To put this in perspective, the height to which a ship is lifted is equivalent to that of a 66-story building. If you were near the Great Pyramid of Giza, you'd see that its height is 139 meters from above, while the Statue of Liberty in the United States stands only 93 meters tall. This makes one truly admire the ingenuity of Chinese engineers, as a lift height of 199 meters is almost unimaginable. Under normal circumstances, a river with such a dramatic elevation drop would be non-navigable. Yet, through advanced engineering techniques, the Chinese have achieved this astonishing feat, earning them the well-deserved nickname Infrastructure Maniac. Moving on, after a ship passes through 2 of the elevators, it must then be lowered in some way to reach the water behind the dam. To accomplish this, the system includes an additional elevator at the end of the mountain route, with a maximum lowering height of up to 47 meters, again, depending on the water level. Incidentally, in terms of throughput, this system might appear rather rudimentary. Although the ship is raised relatively quickly, it can accommodate only one vessel at a time, meaning that the elevator system's capacity is not very high. In fact, it might even lead to long queues waiting for the elevator. However, once one ship passes through the first elevator, the next can immediately be raised. While this arrangement is not perfect, the design engineers have done their utmost to expedite transportation along this single route, comprising 3 elevators and a section of water conduit. The system makes elevation changes extremely simple and undoubtedly represents yet another astonishing achievement of Chinese engineering. There remains a certain distance between the elevators that must be traversed, but in this case, it poses no significant challenge. Traditionally, locks are used to transfer vessels between different elevations without needing to cross mountains. Multi-level elevation changes are typically achieved by installing several locks that slowly raise or lower a ship step by step. However, here the vessels must navigate among mountains. Initially, there was no river beneath the elevator system at all, so in addition to constructing the 3 elevators, another feat had to be accomplished, laying a passage between them. Ultimately, the main passage between the 2 elevators and the mountain is an open water conduit. This does not mean that building such a passage is uncommon. Ancient engineers achieved similar feats without modern high-tech. But in this case, integrating the waterway system with rugged mountain terrain and the entire elevator system greatly increased the challenge. Nonetheless, Chinese engineers successfully overcame these difficulties, completing the second mountain crossing route. In fact, you need not even wonder how China managed it. The country has accumulated considerable experience in tunnel construction, using giant tunnel boring machines to excavate tunnels so that everything is completed as planned. As a result, a mountain route spanning 2.3 kilometers was born. The entire project cost a staggering $7.775 billion, and it is precisely because of this ship lift system that vessels are able to traverse the most perilous terrain. If a more traditional lock system were used, each ship would undoubtedly encounter far more difficulties during its journey. You may have already realized that the water conduit and elevator system were built specifically because the Goupitan Dam is located in this region. This ship lift system is one of the fundamental supporting facilities of the dam. In summary, the Goupitan Dam and its hydropower station are not particularly remarkable in themselves. The only unique aspect is their highly advantageous navigation system, which allows ships to effortlessly fly over mountain ranges. This raises another question. Why did China need such an enormous investment, consuming vast amounts of effort, time, and capital, to build this system, especially when the project itself doesn't seem all that grand? First, let's take a look at the location of the dam and its navigation system. For ships, this area is narrow and environmentally harsh, to the extent that using a traditional lock system was simply not feasible. It's worth noting that after the completion of the Goupitan Dam, Chinese engineers undertook significant work overall. Building any dam creates a barrier in the river, causing water to accumulate on one side and leading to a rise in water levels on the other. Although in some places, this difference in water levels might not be very noticeable. In the case of the Goupitan Hydropower Station, the water level difference is so immense that designers had to abandon a single ship lift system, as lifting ships in such a manner would not only be time-consuming but also extremely dangerous. Therefore, constructing a dam and hydropower station in this context became essential, even though the project itself required enormous labor and substantial costs. Therefore, to both develop new energy in the region and establish a water transport network, Guizhou built the Goupitan Hydropower Station and its ship lift system, which has an annual cargo capacity of 2.928 billion tons. Some might argue that using semi-trailers or rail cars to transport goods is also feasible, but these methods are less efficient. For example, a standard truck can carry about 23 tons, while the Goupitan ship lift can hoist a 500-ton ship, and this is not even the limit. In fact, a single barge can replace dozens of trucks. Considering the road construction in Guizhou's mountainous areas, it is nearly impossible to build wide highways suitable for large numbers of small trucks and tourist vehicles. Allowing trucks to navigate narrow mountain roads and bridges poses significant risks, since water transport exists, and barges and other cargo ships are more fuel efficient. Rail transport, while slightly better, faces its own challenges, such as the difficulty of laying tracks and the overall lower efficiency of rail freight compared to water transport. Despite the various challenges associated with the ship lift system, this region has achieved the optimal solution through massive investment. As a result, we are able to witness such a spectacular sight and understand how real it is to sail ships through mountains. After all, a ship lift capable of hoisting 10,000 tons is itself an incredible feat of engineering. The completion of this engineering project has left a profound impression on netizens abroad. Many remarked, "The ship lift alone is jaw-dropping." This navigation channel built on the towering bridge of the Goupitan hydropower station is a world-class aquatic viaduct with design and construction quality that's simply mind-blowing. And the water tunnel cutting through the mountains, that's pure genius. China achieves such incredible infrastructure for less than half the cost of a single Arleigh Burke-class destroyer, all while maintaining navigation on a major river. What a bargain! Others added, projects like this feel almost routine for China, yet they're engineering marvels. If this were in the US, it would take roughly 50 years to plan and another 50 years to build, if it ever got done at all. While some comments may be exaggerated, they undeniably reflect the staggering capabilities of China's modern engineering prowess. Let's take a look at the ship lift at China's Three Gorges Dam. This lift system can hoist ships weighing up to 3,000 tons, completing a round trip in just 40 minutes, numbers that are staggering on their own. As the saying goes, with great power comes great size. The lift's chamber measures 122 meters in length and 18.3 meters in width, holding a volume of water equivalent to 4 Olympic-sized swimming pools. Its colossal scale allows it to accommodate nearly any vessel at maximum capacity. Imagine lifting a ship of such immense weight to a height of 113 meters above the ground. It's an almost unbelievable feat, but it must be pointed out that raising such an enormous weight to a sufficiently high altitude with a single lift is in itself an extraordinary achievement, and we cannot overlook the brilliant ingenuity of Chinese engineers. Chinese engineers have also put a great deal of effort into safety. They have installed 4 sets of symmetrically arranged drive mechanisms, equipped with gears and supports that firmly reinforced the 4 corners of the ship's cabin. This setup effectively eliminates the adverse effects caused by the tilting or swaying of the water inside the cabin, and it greatly reduces the risk of capsizing. The designers have also ensured that even in emergency situations, such as during an earthquake, the system remains safe, because the lift cabin is equipped with cushioning devices that absorb vibrations and shocks. A construction expert involved in the project highlighted the seismic protection system. It dissipates seismic forces across multiple support pillars. This design prevents chamber collapse and other catastrophic failures. Since the commissioning of the multi-stage lock system at the Three Gorges Dam, its benefits have already begun to emerge. According to media reports, the dam's cargo throughput reached 100 million tons in the first half of 2024, marking a 10.32% year-on-year increase and setting a new historical record for the Three Gorges locks. As you might expect, before the ship lift became operational, vessels still needed to traverse the dam, a process enabled by another engineering marvel, the 5-stage lock system. Installed adjacent to the dam are 2 parallel lock complexes, each consisting of 5 chambers, with a total transit time of approximately 4 hours. This time gap, 40 minutes versus 4 hours, is precisely why China is prioritizing the construction of a new lock system. Such delays could severely impact individual businesses and even the broader Chinese economy, given that the Yangtze River serves as a critical maritime artery with no viable alternatives. But just how impactful are these locks? Even with a 4-hour transit per vessel, the dam's annual cargo volume hit 180 million tons in 2024, and this figure continues to grow alongside China's economic expansion. Notably, initial projections estimated a maximum annual capacity of just 100 million tons, a number that has been clearly underestimated. Some say that China's development is an epic written in steel and concrete. From the natural barrier of the Yangtze River to the extremes of the Qinghai Tibet Plateau, from underground tunnels spanning 1,000 meters to bridges reaching the clouds, 1.4 billion Chinese have carved paths through mountains and tamed mighty rivers across 9.6 million square kilometers of land. They have etched the trajectory of a nation sprinting toward modernization. In 2018, a colossal steel dragon leaped out of the Lingdingyang. This bridge stretches 55 kilometers, built over 6 grueling years by tens of thousands of workers, with 33 immersed tube sections connected with an accuracy of no more than 4 centimeters. The Hong Kong-Zhuhai-Macao Bridge, backed by 400 patents, answered the world's skepticism. While the West claimed that complex geology made bridge building impossible, Chinese engineers used an integrated bridge island tunnel approach, reducing travel time from Zhuhai to Hong Kong from 4 hours to just 40 minutes. This is not just a bridge, it's a declaration of a nation breaking through its constraints. Cutting paths through mountains and building bridges over waters is never just a metaphor, it is the survival philosophy of the Chinese people. In this video, we're diving into a topic that will set your heart racing: China's mega projects. These feats not only leave the world in awe, but have also transformed our daily lives. But do you know how they were built? What are the untold technological secrets behind them? Stay tuned, as today we unveil the mysteries of these extraordinary engineering marvels. On this map of China, it's not highways or railways that crisscross the nation like veins, but rather, one bridge after another. To date, over 960,000 bridges of all kinds, highway bridges and high-speed railway bridges included, have been constructed on Chinese soil. In fact, nearly 45.2% of the 40,000 kilometers of high-speed railways are built on bridges. These marvels span towering mountains and rushing rivers, connecting towns and villages, making China a country of bridges. Truly, the title infrastructure maniac lives up to its name. When renowned British motoring expert Jeremy Clarkson first visited China, he was absolutely blown away by the country's infrastructure. Driving along China's highway bridges, he remarked,
"In 1988, China had no motorways at all. And now, 30 years later, it has 84,000 miles of them. That's more than any other country in the world. And they're only just getting into their stride. Since 2011, they've been building 6,000 miles of motorway every year. 6,000 miles a year! It beggars belief, and it's not like the terrain is easy. Here, though, there ain't no mountain high enough, and there ain't no valley low enough to stop them. This bridge, for example, is 34 miles long. And then there's this one, the Goupitan Bridge. You could fit the London Shard underneath it, twice over. I'm telling you, in Britain we're doomed.
That's right. When it comes to bridge building technology, Britain simply can't compare to China. In the world of bridge engineering, there's a famous saying: for bridge construction, look to Europe and America before the 1970s, to Japan in the 1990s, and to China in the 21st century. Today, China's bridge construction has reached the world's top tier. Chinese bridges have become not only a shining postcard of China, but also an important symbol of its comprehensive national strength. Over half of the world's long-span bridges are built by Chinese engineers. In the rugged mountains of southwest China, a colossal steel dragon soars into the sky, linking the provinces of Guizhou and Yunnan. This is the Beipanjiang Bridge, once hailed as the world's highest bridge, a title now surpassed by another marvel built by Chinese engineers. Curious about which bridge it is? Make sure to subscribe to my channel. We'll reveal all the details in the next video. The vertical distance, from the bridge deck to the valley floor of the Beipanjiang Bridge, reaches 565 meters. Equivalent to 200 stories high. Building such a long-span bridge is no easy feat. The Beipanjiang Grand Canyon boasts treacherous terrain, complex geological conditions, and is subject to relentless winds, dense fog, and low temperatures. No one had ever thought it possible to construct a bridge in such an extreme environment. Yet, Chinese engineers were not intimidated by these challenges. With ingenuity and courage, they overcame obstacle after obstacle. To build bridge piers on such steep cliffs, engineers invented the moving formwork system, assembling the piers section by section like building blocks. They also utilized smart concrete, a material that automatically adjusts its temperature to prevent cracking, ensuring the piers are both robust and durable. The two concrete main towers of this bridge stand majestically, with the tallest reaching 883 feet, equivalent to the height of a 90-story building. The bridge deck is constructed from 22,000 tons of steel, with a total weight equal to that of 5 Titanic ships. The vertical distance from the valley floor to the bridge deck even surpasses the height of the New York World Trade Center, enough to fit an entire skyscraper. The total length of the bridge's steel cables reaches 250 miles, which, if stretched out, could extend from New York City all the way to Washington, D.C. The entire bridge spans the canyon, measuring about 1 mile in length, while the highest point of the tower peaks at 2,461 feet. The height, from the valley floor to the tower's tip, is greater than the combined height of 2 Eiffel Towers, plus the Statue of Liberty. Such a scale of engineering and technical difficulty represents the pinnacle of human bridge building history.
Nice.
This level of engineering and technical difficulty is not only a masterpiece in the history of bridge construction. The Beipanjiang Bridge began construction in October 2010 and officially opened to traffic in December 2016. Upon its completion, it immediately caused a global sensation. Major media outlets rushed to cover the story.
Well, a walk across a new bridge in China could send your heart racing because it's the world's highest, and it opened today. It stands more than 1,800 feet above the valley below, and that's more than a third of a mile. The bridge cuts the drive time between two southwest Chinese cities from 4 hours to just 1.
John Davis, president of the American Society of Civil Engineers, admitted, if this bridge were built in the United States, it would take at least 20 years. Yet Chinese engineers completed this epic super project in just 6 years. Such speed is extremely rare in the history of bridge construction. They even installed AI monitoring systems on both sides of the canyon to adjust the tension of the steel cables in real time. The sheer capability to execute such a massive engineering project makes it hard to believe that China is still considered a developing country. It's simply more impressive than anything achieved by any developed nation. But the speed myth of Chinese engineers reached its peak with the reconstruction of an urban bridge. Next, let's take a look at how Chinese engineers built a bridge in under 43 hours. That's right. This is the construction process of Beijing's Sanyuan Bridge back in 2015. Although 10 years have passed, it still leaves people in awe. The United States should learn from China on how to build bridges faster. I just hope that the US stops attacking China, but honestly, I think they're just jealous. Such high efficiency and top-notch construction simply can't happen in the US. In 2015, the time-lapse video of Beijing's Sanyuan Bridge being rebuilt in just 43 hours quickly went viral worldwide. The video was only 30 seconds long, but its views skyrocketed. It captured the entire reconstruction process by Chinese engineers, from the start of construction to the full reopening of traffic, all completed in just 43 hours. Foreign netizens were stunned. While praising China's incredible speed, they couldn't help but roast their own countries. An Indian netizen commented that such a project in India would take at least 5 years. An American netizen said that if this were in the US, it would take at least 20 years to complete. Meanwhile, Chinese engineers finished in less than 2 days what would take 20 congressional hearings and 50 revised blueprints just to start in the US. Another netizen jokingly claimed that in their country, such a project would require 3 presidential terms to complete. Another American netizen, after seeing this, was completely shocked. He simply couldn't believe that China was able to build and put a bridge into use in just 43 hours. Because in the United States, building a simple bridge takes years. For example, a street light in front of my house burned out, and it took an electrician 5 months just to fix it. Seeing these complaints from overseas netizens, I can't help but laugh and cry at the same time. Even British academics were in awe of China's infrastructure speed. In one of his academic lectures, he remarked,
China has actually soared. It's meteoric. Former Czech President Václav Havel, I think, put it best. He said, all this has happened so fast, we haven't yet had time to be astonished. To remind myself how astonished I should be, I occasionally look out the window in my office in Cambridge at this bridge which goes across the Charles River between the Kennedy School and Harvard Business School. In 2012, the state of Massachusetts said they were going to renovate this bridge. It would take 2 years. In 2014, they said it wasn't finished. In 2015, they said it would take 1 more year. In 2015, they said it's not finished. We're not going to tell you when it's going to be finished. Finally, last year it was finished 3 times over budget.
The professor then talked about his trip to Beijing, where he drove past the famous Sanyuan Bridge.
Now, compare this to a similar bridge that I drove across last month in Beijing. It's called the Sanyuan Bridge. In 2015, the Chinese decided they wanted to renovate that bridge. It actually has twice as many lanes of traffic. How long did it take for them to complete the project? What do you bet? Take a guess. Okay, take a look. The answer is 43 hours. Now, of course, that couldn't happen in New York.
After these words, cheers erupted throughout the room. The audience's faces were filled with disbelief, staring at the professor in awe, as if saying, this can't be real. It was truly hard to believe. The professor added that this was not just a triumph of technology, but also an organizational revolution. China has taken parallel engineering to the extreme, design, prefabrication, and demolition all happening simultaneously, compressing time to its physical limits. He also pointed out why China has become so powerful today.
Behind this speed and execution is a purpose-driven leader and a government that works. The most ambitious and most competent leader on the international stage today is China's President Xi Jinping. And he's made no secret about what he wants. As he said when he became president 6 years ago, his goal is to make China great again.
That's right. This wise British professor made a very valid point. The Chinese always approach things with incredible efficiency, never dragging their feet. While other countries are still debating bridge construction plans, Chinese engineers have already torn down the old bridge and built a new one. This is the essence of China's speed. When all the braggarts around the world witness China's speed, every other pace seems as slow as a snail. China continues to create astonishing stories for the world. China's speed is the speed of global development. Wherever the Chinese go, construction and progress follow. This is what true global leadership looks like. Time and time again, the speed of China's infrastructure projects has shattered the world's understanding of what is possible. So, do you know how Chinese engineers managed to complete this epic engineering project in just 43 hours? Let's continue. Beijing's Sanyuan Bridge is an interchange consisting of 3 main bridges, 5 ramp bridges, and 7 ramps. It is located at the junction of Beijing's East 3rd Ring Road and North 3rd Ring Road, serving as an important transportation hub in the city. During peak hours, as many as 13,000 vehicles pass through in just 1 hour. The main bridge covers an area of 1,715 square meters, with a total length of 54.3 meters and a width of 44.8 meters. After 30 years of service, the bridge was gradually becoming overloaded, and its surface began to show signs of aging and damage. Following detailed inspections by bridge engineers, it was determined that the bridge's load-bearing capacity had significantly declined. To ensure traffic safety and efficiency, China decided to reconstruct the Sanyuan Bridge. Using traditional beam replacement methods would not only take a long time but also cause severe disruptions to Beijing's traffic. This approach was clearly not in line with China's infrastructure speed. So, the key challenge was, how can the bridge be reconstructed without affecting normal traffic? This was the main problem engineers had to solve. After repeated research and demonstrations by bridge experts, Chinese engineers decided to adopt the bridge replacement method. This method is simple and effective. Remove the existing old bridge and install the new bridge. While this might sound simple, the actual execution was a different story. Although the entire project lasted 43 hours, the original construction plan aimed to complete the process within just 24 hours. So, what unexpected changes occurred during this period that caused the project to be delayed by a full 19 hours? Before the Sanyuan Bridge project officially began, the Beijing Road Maintenance Group used a multi-dimensional platform to break down and reorganize every step of the construction process. Thousands of workers underwent countless 3D animation simulations to ensure that every stage of the construction was well understood. In China, there is a saying, even with 100 careful plans, a single oversight can still occur. Despite such detailed pre-construction planning, unexpected challenges still arose during the on-site execution. At 11 p.m. on November 13, 2015, the Sanyuan Bridge reconstruction project officially began. The first step was to dismantle the old bridge. The original plan was to use 2 1,000-ton beam transporters to carry away the cut bridge sections directly. However, an unforeseen issue occurred. The bridge deck's weight had far exceeded the transporter's carrying capacity. Although the transporters had a maximum load capacity of 2,000 tons, the bridge actually weighed 2,900 tons. To solve this problem, engineers had to first cut and remove the 2 1,300-ton side sections of the bridge, then further cut them into smaller pieces for cranes to lift away. Finally, the central bridge deck was transported away in one piece. It was precisely this unexpected complication that caused the originally planned 24-hour project to be extended to 43 hours. Although dismantling the old bridge caused a delay, the most critical challenge was how to accurately place the new bridge in the exact position of the old one. Once the old bridge was moved to a temporary storage site, the new steel bridge, measuring 54.9 meters long and 44.8 meters wide, was transported into place. However, an even greater challenge emerged. The placement error had to be controlled within 20 millimeters. For the engineers, this was an enormous challenge. To ensure absolute precision, engineers implemented a dual navigation system. Beidou satellite navigation system was used for aerial positioning. Optoelectronic navigation was used for vehicle alignment correction. With this dual precision control system, the final positioning error was reduced to just 9 millimeters, a truly remarkable feat. By 11 a.m. on November 15, 2015, the most technically demanding phase of the project was successfully completed. Once the new bridge was in place, the remaining work was relatively straightforward. In the afternoon, construction began on the road surface, including pouring counterweight concrete, laying asphalt, and installing expansion joints and protective barriers. By 6 p.m., the site was fully cleaned up, and the bridge was officially open to traffic. The entire project took 43 hours to complete, marking the successful reconstruction of the Sanyuan Bridge. During this reconstruction, Chinese engineers skillfully utilized advanced technologies such as Beidou positioning systems, laser alignment, and infrared positioning to ensure accuracy and efficiency. Although some challenges were encountered, the project was successfully completed in the end. The Sanyuan Bridge reconstruction project was the first time in China that a large-scale bridge replacement was completed in a single operation at an important traffic hub. On a global scale, this level of efficiency and technological precision is even more groundbreaking. While Western countries are still debating the so-called democracy efficiency paradox, Chinese engineers have proven with the Sanyuan Bridge project what true speed and efficiency look like. As the New York Times commented, China is redefining modern governance with Tesla-style innovation in the infrastructure sector. Chinese engineers also accomplished the remarkable feat of building a train station in just 9 hours, sparking heated discussions and debates internationally.
How the Chinese do these things, they were able to build a whole new station in the space of 9 hours by flooding it, thousands of workers. We should be much more imaginative about getting infrastructure in instead of condemning people to being isolated in remote areas.
Was it 9 hours they built?
9 hours.
Sounds
Look
like
it
a
up.
television reality
There is
show.
a video here. You've got to watch
We can't get the workers
this
out
thing.
to take the
Nice.
When comparing construction efficiency abroad, it's easy to see why China is often called the infrastructure maniac. Take New Zealand, for example. A 300-meter subway line in the city center has been under construction for 4 years, and it's still not finished. In China, a similar project would take less than 2 years to complete. Foreign construction efficiency often raises eyebrows. Work stops if it's too sunny, rainy, or windy. On top of that, they only work 6 hours a day, with much of that time spent chatting. In stark contrast, a skyscraper nearby, built by a Chinese team, is already nearing completion after less than 2 years of work. This is just a glimpse of China's infrastructure prowess. Chinese construction projects are not only reliable in quality, but also unmatched in speed. For example, dismantling a flyover takes just 8 hours, renovating a high-speed rail station takes 9 hours, and building a floor of a skyscraper takes only 7 days. These feats have left engineers around the world, especially in the United States, absolutely astonished. So, how powerful is China's infrastructure development capability? Next steps, we'll explore this fascinating topic. Let's start with some striking data. By the end of 2021, China's railway network spanned over 150,000 kilometers. Its road network reached approximately 5.28 million kilometers, and its ports boasted more than 20,000 berths for production use. The country's inland waterways stretched an impressive 128,000 kilometers. Today, China is home to the world's largest high-speed rail network, expressway system, and a network of world-class port clusters. Its comprehensive transportation network exceeds 6 million kilometers. Behind these extraordinary figures stands a remarkable team, often referred to as the infrastructure maniac. They are none other than China's infrastructure development teams. As China continues to achieve record-breaking milestones in construction, its infrastructure innovation capabilities have also seen remarkable growth. By overcoming numerous technical challenges, China has built the world's longest sea-crossing bridge, the largest water conservancy project, the highest altitude plateau railway, and the first smart high-speed railway. Now, let's experience the scene of a Chinese high-speed train departing the station. The sound is amazing. These engineering feats have left the world in awe time and again. From having nothing to its name, to building one floor in just 3 days, and then constructing 2 hospitals in just over 10 days during the COVID-19 pandemic. These examples highlight how China's engineering and construction technology is advancing step by step. Starting in the 1980s, Chinese engineers embraced independent innovation, developing groundbreaking construction equipment, including the world's first air-building machine capable of adding a new floor in just 2.5 days. China mastered kilometer-level skyscraper construction techniques, built over half of the world's 500-meter-plus super-tall buildings, and 90% of the 300-meter-plus skyscrapers within the country, securing its position as a global leader in creating iconic made-in-China landmarks. Turning to railway and highway development, before 1988, China had 0 kilometers of expressways. By the end of 2021, the total length of expressways had reached nearly 170,000 kilometers, firmly ranking first in the world. In 2008, China launched its first high-speed railway designed for speeds of 350 kilometers per hour. In just over a decade, China became the world's leading high-speed rail powerhouse. By the end of 2021, the country's railway network exceeded 150,000 kilometers, with high-speed rail accounting for over 40,000 kilometers, more than 2/3 of the global total, enough to circle the Earth's equator once. Behind these transformative achievements lies the relentless dedication of Chinese engineers. From China's first domestically designed and built railway to the world's first smart high-speed railway, over the past few decades, Chinese engineers have constructed 66% of the world's total railway length, 90% of electrified railways, 55% of high-speed railways, and 60% of urban rail projects. These achievements have written a magnificent chapter in China's infrastructure, especially in railway construction. This is the world-renowned Chongqing Light Rail, showcasing a seamless track-switching process that's nothing short of magical. The advanced technology is truly awe-inspiring, exuding a strong sense of innovation. Even Elon Musk couldn't help but praise it. He posted on his personal social media, stating, "China has incredible trains and infrastructure in general. Alright, let's keep watching." At the same time, China has independently developed a series of heavy-duty equipment, such as the first domestically made plateau, cold region, large-diameter hard rock tunnel boring machine, Snowy Pioneer, and the world's largest diameter TBM, Caucasus. It's one of the world's largest tunnel boring machines, a groundbreaking piece of technology independently developed by Chinese engineers from scratch. The successful creation of this super machine shattered a once formidable technological blockade. For years, the United States, Germany, and Japan dominated this field, leaving others behind. In the past, China had to pay an astronomical $55 million to purchase second-hand tunnel boring machines from these countries, while also incurring hefty consulting fees. But with the development of the Caucasus tunnel boring machine, China has transformed itself into a global leader in mechanical engineering, no longer reliant on foreign technology. The Caucasus tunnel boring machine measures 104 meters in length. It boasts a massive excavation diameter of 16.09 meters. Its total weight is approximately 5,000 tons. Currently employed in the construction of the Yangtze River Tunnel project, it achieves extraordinary feats, drilling over 5 kilometers continuously without replacing its cutting tools. Equipped with a mud-water circulation system and an innovative air cushion chamber, it efficiently manages mud pressure during excavation, preventing ground subsidence and collapse. This ensures the machine maintains a steady tunneling posture. It solves the long-standing global issue, frequent water leakage in large-diameter tunnel construction. Many may not be familiar with how a tunnel boring machine works. Its operation is similar to how a pendulum digs burrows. The cutting head and tools function like the pendulum's front claws, breaking through soil and excavating the tunnel. The shield serves as the pendulum's sturdy back, supporting the newly formed tunnel and preventing collapses. The soil removal system works like the pendulum's hind claws, transporting the excavated material out of the tunnel. Finally, the machine's tunnel segments resemble the pendulum's scales, reinforcing the tunnel for added strength and stability. Today, China's tunnel boring machines are entirely domestically manufactured, free from the constraints of foreign technology blockades. This remarkable achievement showcases the country's rapid progress in both large-scale machinery design and production. Today, these advancements surpass those of many developed nations. China is on track to rival and potentially surpass the mechanical engineering prowess of the United States and Germany. But that's not all. China has also built the first electrified railway in Tibet, the Leyland Railway, the China-Laos Railway, a flagship belt and road project. The China-Laos Railway officially began operations in 2021. Starting in Kunming, China, it crosses the border at Mohun Town and extends to Vientiane, the capital of Laos. Designed for a speed of 160 kilometers per hour, the railway adopts the Chinese standard gauge, enabling seamless connectivity with China's vast railway network. The world's longest sea-crossing rail and road bridge, the Pingtan Strait Bridge, along with many other monumental projects that benefit the country and its people, while connecting the world. With reliance on technology and self-reliance, China has also developed the largest diameter shield tunneling machine, the Jinghua, and the world's first 1,000-ton bridge erection machine, the Kunlun, both marking significant milestones. Today, the Kunlun has helped complete the world's first sea-crossing high-speed railway, and the dream of taking the high-speed train to see the sea is soon to become a reality. At the same time, CCCC has also established over 70% of national standards for the water transport industry, designing and constructing more than 80% of the nation's deep water coastal channels, with notable advantages in bridge design and construction, channel dredging, and manufacturing. Randi, CCCC has independently designed and built Asia's largest cutter suction dredger, the Tianquan. The Tianquan Hao can fill an entire football field with sand in just 1 hour, with a sediment transport distance of over 10,000 meters, measuring 140 meters in length and 27.8 meters in width. It boasts a maximum dredging depth of 35 meters and a design displacement of 17,000 tons. This engineering marvel has not only broken the long-standing monopoly of Western countries but is also the largest cutter suction dredger in Asia. From spending the equivalent of 4 tons of gold to purchase dredgers from Europe and America, to now achieving technological independence, Chinese engineers and construction teams have created yet another miracle. The Tianquan Hao is primarily used for dredging river, lake, and sea channels. Equipped with a giant cutting system at its front, it crushes seabed mud and rocks during operation. The onboard mud pumps extract the mixture, transporting it at a rate of 6,000 cubic meters per hour. This enables it to cover distances of over 10 kilometers, ensuring smooth and navigable waterways. But its capabilities go beyond dredging. Its ability to fill a football field in just 1 hour has earned it the nickname of an island-building machine. Remarkably, within just a year of completion, it was used to construct 8 islands at sea. The Tianquan Hao represents a major leap forward for China's manufacturing industry, and it holds significant strategic importance. As a result, China has declared that this extraordinary dredger will never be sold or leased to other countries. The world's largest crane vessel, the Jinhua 30, and a series of other heavy-duty national instruments, CCCC has also designed and constructed iconic projects such as the world's largest offshore container port, Shanghai Yangshan Port, and the world's longest sea-crossing bridge, the Hong Kong-Zhuhai-Macao Bridge. When it comes to hydropower station construction, the first thing that comes to mind is the Three Gorges project. Known as the world's largest hydropower station, the construction of the Three Gorges Dam was an enormous challenge. It took nearly 80 years from the initial planning in 1932 to the official commencement in 1994. And finally, comprehensive completion in 2006. Throughout this process, engineers had to overcome various difficulties and risks, such as diverting the flow of the upper reaches of the Yangtze River, while ensuring sufficient water continues to flow downstream. The construction of the Three Gorges Dam is a magnificent feat of the Chinese people and a model in the world of hydraulic engineering. It generates enough power in just 1 second to meet the electricity needs of an average Chinese person for over 4 years. China Power Construction and China Energy Construction played pivotal roles in the construction of the Three Gorges hydropower station. China Power Construction has undertaken nearly all major hydropower projects in China and built over 90% of the country's pumped storage power stations. It holds more than 50% of the global market share for hydraulic and hydropower engineering design and construction. The company has also participated in the world's largest south-to-north water diversion project, the Goupitan Hydropower Station, the highest dam in Africa at Ethiopia's Tikis Dam, and Southeast Asia's largest hydropower station, the Malaysia Bakun Dam. Next, let's talk about the backbone of energy construction, China Energy Construction. This company has completed over 90% of electricity planning, research, consulting, surveying, and design in China, as well as the formulation of industry standards. It has handled 80% of coal-fired power plant surveys and designs, 60% of coal-fired power plant construction, 50% of large hydropower construction, and 90% of ultra-high voltage power transmission line surveying and design. It has also undertaken significant projects such as the world's largest wind-solar storage power transmission project, the first multi-terminal flexible DC transmission project, and the first ultra-high voltage multi-terminal hybrid DC project. Over the years, one bridge after another has risen, crossing treacherous landscapes. Railways stretch towards the horizon, providing convenience for people's travel. Chinese engineers have built China's roads, China's bridges, China's ports, China's tunnels, China's cities, and China's dams, shining national symbols that fuel the powerful momentum of China's economy. So, returning to the original question, how strong is China's infrastructure? From skyscrapers, railways, highways, and bridges to water conservancy, energy, and industry, from transforming a train station in 9 hours, rebuilding a flyover in 43 hours, moving a railway in 5 hours, to dismantling a bridge in 2.5 hours, you must now have the answer in your mind. The world remains the same, but China is no longer the same China. With the infrastructure powerhouse taking on the heavy responsibility and historical mission, it will continue to push forward, innovate, and drive China's giant ship steadily toward a promising future. Chinese engineers have crossed great rivers, mountains, valleys, straits, and bays, connecting this vast country as one. Initially, China had only a 9.3-kilometer railway, a steel bridge with a main span of 63 meters, and a tunnel 261 meters long. It wasn't until 1937, when the Hangzhou-Qiantang River Bridge was completed, that China had its first self-designed and built railroad bridge. However, to resist the Japanese invasion, the bridge's designer, Mr. Mao Yisheng, had to personally destroy it. It wasn't until the founding of the People's Republic of China that the bridge was fully repaired and rebuilt. In 1957, the Wuhan Yangtze River Bridge was completed, allowing the Chinese to cross the Yangtze River for the first time. Young bridge engineers overcame numerous challenges, successfully designing and building the Nanjing Yangtze River Bridge. Thus, the once distant railways on both sides of the Yangtze were finally connected, giving rise to two major transportation arteries, the Beijing-Guangzhou and Beijing-Shanghai railways. However, the span of these bridges remained limited, unable to accommodate more complex geographical conditions. It wasn't until 1991, with the completion of the Nanpu Bridge in Shanghai, that China began building large-span bridges independently. Since then, China's bridges have become increasingly diverse and grand, not only spanning the Yangtze with a single arch but also soaring across canyons at an altitude of 565.4 meters. Meanwhile, underground tunnel engineering has also made remarkable progress. It took China nearly a century to build its first 10,000-meter tunnel, but in just over 20 years, the country achieved breakthroughs of 20,000 meters and even 30,000 meters. In the past, the Qinghai-Tibet Railway had to climb 600 meters and take 2 hours to cross Guanzhou Mountain. But today, a 32,690-meter-long tunnel allows a direct 20-minute passage through the mountain. It is thanks to thousands of tunnels and millions of bridges that China has overcome countless natural barriers, connecting railways and highways to all corners of the country. China now has the world's largest high-speed network and high-speed rail network. This fully connected China can transport 17.6 billion passengers and 462 tons of cargo annually to every corner of the world. Behind these vast numbers is a monumental reorganization of population and resources. Over the course of more than a century, China has connected, reorganized, and rebuilt, breaking the environmental constraints that once held back this land and creating a unique transportation network. 100 years later, the Chinese have reshaped the land. Looking back at the past, the Chinese entered the 21st century carrying the national humiliation of the Eight-Nation Alliance occupying Beijing during the Qing dynasty. However, through the relentless efforts of generations of Chinese people, this once fractured country has finally been restored and unified. China, a nation of resilience and determination, has always commanded utmost respect. Its hard-working people embody the essence of perseverance and dedication. Despite facing numerous challenges and enduring profound pain, they never cease to strive for greatness. China's indomitable spirit is a testament to its unwavering commitment to excellence. In times of adversity, China's deep understanding of humanity shines bright. Their profound philosophical insights encapsulate the essence of compassion, empathy, and unity. China's philosophy of life is a boundless source of wisdom, guiding individuals toward a deeper understanding of the human experience. With its rich history and cultural heritage, China has left an indelible mark on the world. The achievements of its people and their relentless pursuit of progress inspire admiration and awe. Their unwavering determination to make China the best resonates with the hearts of millions. China's contributions to humanity are truly remarkable. From revolutionary advancements in technology and science to promoting peace and harmony in a rapidly changing world, China has proven to be a guiding light for humankind. The values ingrained in Chinese culture, such as respect, integrity, and honor, serve as a beacon of inspiration for people around the world. Let us celebrate China, a nation that continues to grow and prosper against all odds. Let us cherish its commitment to humanity and tireless efforts to uplift both the nation and the world. China's unwavering spirit and deep understanding of humanity elevate it to a position of admiration and respect. May China continue to shine bright, leading the way toward a better and more compassionate future for all. The journey through China's mega projects is one of awe and inspiration, a testament to human ingenuity, innovation, and the relentless pursuit of progress. Each of China's major projects showcases the remarkable feats that can be achieved when vision, technology, and sheer determination come together. With each mega project built, China continues to overcome world-class engineering challenges through innovative techniques and advanced construction methods, earning it the moniker Infrastructure Maniac. Moreover, China has undertaken major projects in numerous other countries, each emblematic of its development drive. Behind China's global leadership in infrastructure lies not only a leap in technology, but also the support of a mighty nation. For over a century, from the devastation at the founding of the People's Republic of China, it has been the successive struggles of generations of Chinese engineers that have painted the picture of today's prosperous China. And yet, this is not the end for China. In the future, the infrastructure maniac will continue to help more developing countries modernize, create new opportunities for development, and build a better, more livable world for all. Each bridge, every road, and every project connects cities and countrysides, the present and the future, China and the world. Chinese infrastructure has not only reshaped the face of China, but also exemplified the strength, spirit, and speed of the nation. The infrastructure maniac will never stop. What miracles do you think Chinese infrastructure will create in the next decade? Please share your thoughts in the comments, and don't forget to subscribe and hit the bell. See you in the next video.